Hello everyone, I am Dr.B.Krishnaveni, working as an assistant professor in the Department of Mathematics, Aditya University. Today, in this lecture, we are going to discuss about properties of eigenvalues. So, what the today's lecture outcome is, that is learning outcome. At the end of this lecture, student will be able to apply the properties of eigenvalues. So, in ease, by means of these properties, how the student can find out eigenvalues. Properties of eigenvalue. Here we are listing the properties of eigenvalues and let us discuss one by one. What is the first property is? The matrix is A and its a transpose have same eigenvalues. That is, what the first property is telling is A and A transpose having same eigenvalues. Which means by using this property, if you know the eigenvalues of A, and if you want the eigenvalues of its transpose, means no need to find out transpose of that matrix and once again calculating the eigenvalues. So just we can use this property and conclude that both A and A transpose have same eigenvalues. The second property, the sum of eigenvalues is equal to trace of the matrix. The trace of the matrix is sum of its diagonal entries. We all know that what is meant by trace of the matrix. Trace of matrix is nothing but sum of its diagonal entries. And here the property is the sum of eigenvalues is equal to trace of that matrix. And the product of eigenvalues is equal to determinant of the matrix. Here the property 2 and 3 are representing what is the sum of eigenvalues and what is the product of eigenvalues. The sum of eigenvalues is equal to trace and the product of eigenvalues is equal to depth of the matrix. Coming to the fourth property, if A matrix is invertible, means the matrix have inverse matrix, then none of its eigenvalues are 0. That is the fourth property. Now, if we consider the matrix which is symmetric, that if the matrix is symmetric, then all of its eigenvalues are real. Coming to the next property, that is sixth property. If lambda is an eigenvalue of A, then what is an eigenvalue of A inverse is just the reciprocal of that, that is 1 by lambda is an eigenvalue of A inverse. Very important, one of the important property it is, which means if you know the eigenvalues of A, that is lambda, 1 by lambda representing the eigenvalue of A inverse. Next property, that is seventh property is, if lambda is an eigenvalue of A, then lambda power n is an eigenvalue of A power n. That is seventh property. Eighth property. If lambda is an eigenvalue of A, then lambda plus k is an eigenvalue of A plus ki. Now the ninth property is about, if lambda is an eigenvalue of A, let us consider any polynomial, that is a square minus a lambda plus bi. For this polynomial, what is an eigenvector will be equal to? This will be that is lambda square plus a lambda plus b. Which means if you substitute lambda is equal to, a is equal to lambda, then that becomes the eigenvalue for this polynomial. So means if lambda is an eigenvalue of A, we can say that f of lambda is an eigenvalue of f of A, where f of A representing a polynomial in A. That gives this ninth property. The eigenvalues of a triangular matrix are elements of a diagonal. So if you consider any triangle, either it may be upper triangular or lower triangular matrix, what are eigenvalues? The elements of diagonal are the eigenvalues. The eigenvalues of the diagonal matrix are again representing diagonal elements. That is 12th property. For a real symmetric matrix, the eigenvalues, the eigenvectors corresponding to two distinct eigenvalues are orthogonal. If we consider any real symmetric matrix, this is the property satisfying. What the property is? The eigenvectors corresponding to two distinct eigenvalues are orthogonal. That is the properties. So here we have listed all the properties of eigenvalues. One is A and A transpose have same eigenvalues. Sum of eigenvalues is equal to trace and product of eigenvalues is equal to determinant of a matrix. Invertible matrix means none of eigenvalues are zeros. If A is a symmetric matrix means all the eigenvalues are real. And remaining 6, 7, 8, 9 properties representing how to find the eigenvalue for the corresponding one. That is, if lambda is an eigenvalue, then 1 by lambda is an eigenvalue of A inverse. If lambda is an eigenvalue of A, lambda power n is an eigenvalue of A power n. If lambda is an eigenvalue of A, then lambda plus k is an eigenvalue of A plus ki. And for the polynomial, if lambda is an eigenvalue of A, then f of lambda is an eigenvalue of f of A. And here it is triangular matrix. For diagonal matrix, the diagonal elements are representing eigenvalues. And the property, if the matrix is a real symmetric, then the eigenvectors corresponding to two eigenvalues are orthogonal. These are the properties. Actually, here, if you see this 9th property, 10th property is missing. Actually, what is the 10th property means? If lambda is an eigenvalue of A, then det A by lambda is an eigenvalue of adjoint of A. That is the 10th property. Thereafter, 11th, 12th, and 13th. So now by using these properties, now you can see how easily you can find out the eigenvalues for this question. Given A is equal to 2 by 2 matrix given by 8 minus 4, 2, 2. Now in order to find out the eigenvalues for A inverse, A square adjoint A and the polynomial, that is 2A square minus 1 by 2A plus 3I for given A. First of all, let us calculate the eigenvalues of the given matrix. So for that, first we need characteristic equation. For this, the characteristic equation is det A minus lambda I is equal to 0, which is det of A minus lambda minus 4 to 2 minus lambda is equal to 0. Finding the determinant of 2 by 2 matrix, you got this is equal to A minus lambda into 2 minus lambda minus 8. Minus of minus is plus 8, which is equal to 0. On simplification, you got the polynomial as lambda square minus 10 lambda plus 24 is equal to 0. On simplification, lambda square minus 10 lambda plus 24 is equal to 0. On solving this equation, we got lambda is equal to 4 comma 6 representing eigenvalues of A. So now come to the first question. What is the first question is? We need the eigenvalues of A inverse. So one of the property. What is the property is if lambda is an eigenvalue of A, then 1 by lambda is an eigenvalue of A inverse. By using this property, now we have 4, 6 are the eigenvalues of A. Therefore, 1 by 4 and 1 by 6 are eigenvalues of A inverse. Coming to the second question. A square. So already we know the property. If lambda is an eigenvalue of A, then lambda power n is an eigenvalue of A power n. Now by using this property, 4 square comma 6 square are eigenvalues of A square. So see how easy, how much easy it is finding the eigenvalues if you know the eigenvalues of A by using the properties. Now coming to the third, adjoint A, we need the eigenvalues of adjoint A. And what the property is, if a lambda is an eigenvalue, det A by lambda representing eigenvalue for this adjoint A. So for that we need det A. Det A is equal to A det of 8 minus 4 to 2, which is equal to 16 plus 8. That is equal to 24. And as already we calculated what are the eigenvalues of A, those are 6. That is for lambda is equal to 4, det A by lambda, that is 24 by 4, that is equal to 6. For lambda is equal to the second eigenvalue, which is 6. 24 by 6, that is equal to 4, representing the eigenvalues of adjoint A. Now finally the D question, that is the polynomial. What is the property we need to use for this? So we can find out this in the first slide. This For this, we need to find out eigenvalues. So we have the property, if lambda is an eigenvalue of A means f of lambda is an eigenvalue for f of A. Use this property. We calculated already the eigenvalues of A are given by 4, 6. Now make use of this. F of 4 and f of 6 are representing the eigenvalues for f of A. That is f of 4, 2 into 4 square minus 1 by 2 into 4 plus 3 is one eigenvalue. 2 into 6 square minus 1 by 2 into 6 plus 3 is the second eigenvalue for this question. So by using this properties, it is very easy to find out the eigenvalues corresponding to any kind of these matrices. So this is another question which giving. So eigenvectors here I am not calculating, only I will focus on eigenvectors. For this, A inverse, A square and adjoint A. Clearly the given A is a triangular matrix. As we know, one of the property, if A is a triangular matrix, the diagonal elements are eigenvalues. So what are eigenvalues of A now? The diagonal elements which are given by, since it is triangular matrix, which are given by 1, 2, 3. These are the eigenvalues of A by means of one property. Now A question is, using the property, if lambda is an eigenvalue, 1 by lambda is an eigenvalue of A inverse. So that is 1, 1 by 2, 1 by 3 are the eigenvalues of A inverse, and A square. A square eigenvalues are 1 square, 2 square, 3 square are the eigenvalues of A square. And adjoint A. Need to find out the determinant of this matrix and need to find out det A by lambda gives the eigenvalue for adjoint. So this is the way to find out eigenvalues by applying the properties. In this lecture, what we have discussed is properties of eigenvalues and how to apply the properties and make easy to find out eigenvalues for the given matrices. Thank you.